Happy morning to all of you. Welcome to KB Worker online class. Today we will discuss on the topic Nernst equation of the chapter electrochemistry. So let's start our discussion. Before going to the equation, Nernst equation, first you should know about what is electrode potential. And in previous class already we have discussed this. Again I am telling, when it is the tendency of an electrode to oxidize or reduce, that is called a electrode potential. And if it oxidize, it is called a oxidation potential, and if it reduce, it is called as reduction potential. And in present context, electrode potential means reduction potential. Consider a metal N. It is immersed in its solution, salt solution, and in its salt solution. For example, if you take copper metal, it will be placed in the salt of any copper salt solution. Copper, you can be copper sulfate, any other salt also. If you take zinc, it will be the salt of zinc solution. Then there exists a potential difference between this metal in solid form and its aqueous form, that is iron form. That is called a electrode potential. Now the question is, here one diagram and here one diagram. What is the difference between these two? Here the concentration of the solution may be any concentration, but here the concentration of the solution is taken as 1 m. So if the concentration of the solution is 1 m at 1 bar pressure, standard pressure, the electrode potential is called a standard electrode potential. It is repeated as E naught n/m. We are writing first ion then solid because it is in reduction form. n plus by gaining electron it will convert into m. So here it is standard electrode potential and here the electrode potential at any concentration. Now Nernst equation gives a relationship between the electrode potential and the concentration of the solution. This concentration of the solution and what will be the value of electrode potential. That relationship is expressed in the form of Nernst equation. So for that, consider a general reduction reaction. Because we are taking the electrode potential, and in electrode potential there is reduction potential, so the equation should be written in reduction form. So this is a reduction reaction. For this, the Nernst equation can be written as E m plus slash m, that is electrode potential at any concentration, equal to electrode potential at standard condition. It means standard electrode potential minus RT by NF ln concentration of m, this one, by concentration of m plus, this one. Right hand side divided by left hand side. And in the previous class, in class 11, we have discussed that the concentration of pure solid and pure liquid is 1. So you can substitute in place of m, you can take 1, and when you convert ln to log, you have to multiply with 2.303 RT. So this equation can also be written as E m plus slash m equal to E naught m plus slash m, it remains same, minus, here it is changed, in place of ln it is log, so I have multiplied 2.303 RT NF log, in place of concentration of m it is substituted 1 by concentration of this ion. Now what is R? Your R is your gas constant. That is, the value is 8.314. What is F? It is Faraday constant. Already we have discussed. It is 96,500 coulomb, nearly equal to. Now at 298 Kelvin, if you try to write this equation, means you have to substitute the value of R, T and F. And if you simplify, its value will come 0.059 by M. What is this N? N is the number of electrons involved in the electrode process or the reduction reaction. This is the value of N. So this is the Nernst equation, general form of Nernst equation at 298 Kelvin. But at any temperature, this is the Nernst equation. This is the Nernst equation at any temperature. But here, this is the Nernst equation at what temperature? 298 Kelvin. But in your textbook, the numerical table comes at In numerical it is mentioned that it is at 298 Kelvin. So here should remember this equation. Now we will apply this equation in case of cell. So for that example, Daniel cell. You know Daniel cell? Zinc is the anode and copper is the cathode. It can be represented as Daniel cell is zinc slash Zn2 plus, short bridge Cu2 plus slash copper. The left hand side is anode, this one is an anode, and right hand side is cathode. So now we will write the Nernst equation for each electron, for anode as well as for cathode. So what is the anode reaction? Anode reaction is zinc is oxidized to Zn2 plus. This is the anode reaction. So before writing the Nernst equation, the equation should be in reduction form. So you have to, this is oxidation form. Loss of electron. How can you make it reduction form? Just reverse it. If you reverse it, it will become in reduction form. So if you reverse it, it will become like Zn2 plus 2 electron gives rise to zinc. So if you apply the Nernst equation, this one. So in place of E and N plus slash N, you can write E Zn2 plus slash Zn. In place of E naught and N plus slash N, you can write E naught Zn2 plus slash Zn. The value remains same because we are writing at 298 Kelvin temperature. What is the value of N? What is the value of N here? Here how many electrons are involved? How many electrons are involved? 2 electrons. So the value of N is 2 log 1 by Zn2 plus. Similarly, you can write the Nernst equation for cathode also, that is for copper electrode. For that you have to write the equation. Here copper Cu2 plus is changed to, you see this one, Cu2 plus is changed to Cu by gain of 2 electrons. So again we apply this Nernst equation. In place of E M N plus slash N, you can write E Cu2 plus slash Cu. Then in place of this you can write Cu. The value remains same. Again here also there are 2 electrons involved. So in place of N you can write 2 log 1 by concentration of copper ion. So this is the Nernst equation for cathode, that is your copper electrode, and this is the Nernst equation for anode, that is your zinc electrode. So now we have to write the Nernst equation for a cell. So you know how to find the electrode potential of cell. That is how to find the cell potential, or the cell potential equal to electrode potential of cathode minus electrode potential of anode. This already you have discussed in the previous class. So now we substitute these values. Substitute the value. We will find the cell potential of the Daniel cell. So in place E cell will be equal to, for Daniel cell we are writing the cell potential of Daniel cell. What forms the cathode? Cathode is here copper electrode. So E Cu2 plus slash Cu. What is anode? It is E Zn2 plus slash Zn. Now substitute the value of Nernst equation for each electrode. In place of copper electrode, what you can write? It will be E naught Cu2 plus Cu minus 0.0595 to log 1 by Cu2 plus minus. In place of zinc electrode, what you can write? This one. This one you can write. In place of zinc electrode, it will be E naught Zn2 plus slash Zn minus 0.0595 to log 1 by Zn2 plus. Now if we simplify, open the bracket, then what will become? E cell will be equal to here E naught Cu2 plus Cu minus E naught Zn2 plus Zn. If you open the bracket, it will become minus, because before the bracket there is minus sign. Keep these two in one bracket, then put minus. Here what is common in this case? Here and here what is common? It is common 0.059 by 2. It is common. Then here written minus sign here, so first it will come 1 by Cu2 plus minus 1 by log 1 by log 1 by Cu2 plus minus log 1 by Zn2 plus equal to, in place of this what you can write? Anyone who can say? Anyone? Ipsita, tell me what is this? E naught cathode minus E naught anode. Can we write E naught cell? Yes. In place of this you can write E naught cell minus 0.059 by 2. You know, log A minus log B, you may put bracket here also, it is common, so you should put the bracket here. So it will be log, you know that log A minus log B, what is the formula? It is opposite, log A minus log B, it is log A by B. So log 1 by Cu2 plus slash 1 by Zn2 plus, or if you simplify again, you will get E cell equal to E naught cell minus 0.059 by n, or here it is 2. Here it is 2 log Zn2 plus concentration by Cu2 plus concentration. So this is the Nernst equation for Daniel cell at 298 Kelvin. So in general, for any cell, how can you write? For example, in any cell, the general equation is like this: A of A plus B of B gives rise to C of C plus D of D, and this involves n number of electrons. Then how can you write the Nernst equation? For this Nernst equation will be E cell equal to, again the same form, E naught cell minus 2.303 RT by NF at any temperature. I am writing first log concentration of product divided by concentration of reactant. Right hand side, what is it? C to the power C. Equilibrium constant you can write C to the power C into concentration of D to the power D divided by reactants concentration of A to the power A into concentration of B to the power B. So in place of this, can you write QC? Reaction question in class 11 we have discussed. So E cell, you can write E naught cell minus, if you want to write at 298 Kelvin, so it will be 0.059. If it is at 298 Kelvin, its value is reduced to 0.059, and numerical generally it comes at 298 Kelvin temperature. So you should remember this value. It is log QC. In place of this you can write QC. This is the simplified form of Nernst equation for a general equation of a cell. Now we will apply this to a particular cell so that you can clearly understand the concept Now I am going to write the Nernst equation for a cell. Question may come, write the Nernst equation. There is a question. Write the Nernst equation for the following cell. For the following cell. Aluminium slash aluminium ion, solved with nickel 2 plus slash nickel. Write the Nernst equation for this cell. So it is not necessary to write the Nernst equation for each electrode, then subtract, then you have to write the Nernst equation for the cell. Directly we can write the Nernst equation for the cell. So for that, first you write the net equation of the cell. You know, this is the anode and this one is cathode. So here aluminium is changed to aluminium ion, Al3 plus. How many electrons? 3 electrons. So you write the net equation in this form, general equation. If you can write the general equation, you can easily write the Nernst equation for the cell. Then here right hand side at cathode Ni2 plus, it is changed to Ni. How many electrons? 2 electrons. Right hand side or left hand side? Abhishek, how many electrons? 2 positive means 2 electrons. On which left hand side? Good. So it is. Then you write the net equation. Here how many electrons are there? 2 electrons. And in the oxidation reaction, how many electrons are there? 3 electrons. How to make them equal? How to make them equal? Shivani? Yes, you multiply this with 2 and you multiply this with 3 and add. So it will be 2Al plus 3Ni 2 plus gives rise to 2Al3 plus 3Ni. So before writing the Nernst equation, first you have to write the general net equation. Before writing the Nernst equation, first you have to write the net equation for the cell. Then write the Nernst equation. E cell equal to what? Inert cell minus, if you write in 0. At 298 Kelvin, at 298 Kelvin means 0.059 by N. What is the value of N? Here what is the value of N? Here N is the number of electrons involved in each half cell. In first half cell, how many electrons are there? 2 into 3, 6 electrons. There also how many electrons? 2 into 3, 6 electrons. So N is equal to 6. Many students they commit mistake by writing the value of N. So you must be careful while writing the value of N. It is the number of electrons involved in each half cell, not the total number of electrons. In each half reaction, how many electrons are involved? So N equal to 6 log. Concentration on the right hand side, you know, nickel is pure, so its concentration is 1. So no need to write the nickel in solid form. So it will be Al3 plus concentration. What will be the exponent? Stoichiometric coefficient is 2, so it will be to the power 2 divided by left hand side. Again, aluminium is pure solid, its concentration is 1, so no need to write this aluminium at the denominator. Only you have to write Ni2 plus. Ni2 plus concentration. What will be the exponent? The stoichiometric coefficient is 3 to the power 3. So now if the value of this concentration and this concentration will be given and the inert cell will be given, we can find the cell potential. This is all about your Nernst equation. Thank you.